I want to go through how to do the 2021 FRQ that involves the area under a curve revolving a curve around the x-axis and that type of question. And this particular FRQ, I think, looks particularly intimidating. The function they give you definitely doesn't look very friendly, but I want to show you that it actually isn't as hard as you might think it is at first glance. So the question says, a company designs spinning toys using the family of functions y equals cx times the square root of 4 minus x squared, where c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis in the graph of y equals cx times the square root of 4 minus x squared for some c. Each spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches. So I went ahead and I sketched a picture of the function that they give us, and I also wrote out the family of functions that we are given. So part A says, find the area of the region in the first quadrant bounded by the x-axis when the graph of y equals cx times square root of 4 minus x squared for c equals 6. So they're giving us our c value for this, so c equals 6. So to find the area under the curve, I'm going to need to define my limits of integration. Well, this isn't too hard to find where it intersects the x-axis because we see that there's a 0 when x equals 0 and a 0 when x equals 2. So let's do this integral. So I have that the area is the integral from 0 to 2 of 6x times the square root of 4 minus x squared dx. So this integral, as you'll see, you could probably factor this out, but I'm going to solve it using u substitution. So I'm going to say that my u is going to be 4 minus x squared. Therefore, du is negative 2x dx. So now I'm going to rewrite this integral in terms of u, and I'm just going to go in here and put a little negative 1/3 on the inside and then a negative 3 on the outside, just so it's easier for me to remember that I made that change. So I'm going to go over here and then write negative 3, and then I'm just going to leave this as an indefinite integral, and then I'll put my x back in and use those limits of integration. So I'm given negative 3, and then I have the square root of u du. So this just equals negative 3 times 2/3 u to the 3/2. Okay, so we'll see that my 3's will cancel out. Oh no, my 3's will cancel out, and I'm left with negative 2 times, I'm going to plug back in for u, so 4 minus x squared to the 3/2, and then I'm going to use my limits of integration, so 0 to 2. So I'm left with negative 2 times 4 minus 4 to the 3/2, which will just be 0, minus 4 minus 0 to the 3/2. So I'll cross out my zeros, so I'm just left with negative 2 times negative square root of 4 cubed, so this is just 8. So negative 2 times negative 8 equals 16. And that is the answer to part A. Or I guess they told us it was in inches, so we can say inches squared because it's area. Okay, moving on to part B, which I think is probably the most difficult and scary part of this FRQ, but I'll show you how to do it in a way that hopefully isn't too hard. So for B, they say it is known that for y equals cx times the square root of 4 minus x squared, dy over dx equals c, and then in parentheses 4 minus 2x squared divided by the square root of 4 minus x squared. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. For what value of c is this spinning toy? So we want to know what c equals. So I'll just put a c equals question mark. So they threw a lot of information at us. So let's try to break down what they're telling us. So we have our family functions, y equals cx times the square root of 4 minus x squared. And then in the problem, they told me that y prime, or dy over dx, equals c, and then in parentheses 4 minus 2x squared over the square root of 4 minus x squared. And they also told us that our radius, which is just our y value, because if we look at this picture and we think about this being spun around the x-axis, this is our radius. So, and they're telling us that this is equal to 1.2. But another important piece of information that they're giving us in this question is that this radius is the largest radius. So if something is the largest radius, that means it's the maximum. And this will help us assign a value to this derivative that they gave us. So when something is a maximum, we know that that is where it flattens out and where its rate of change equals 0, which you can see here where I drew the tallest radius is where the function flattens out and its rate of change is 0. You could think of this as like a mountain. If you're climbing up the mountain and then you get to the peak and you can't gain or lose elevation there, and then you start to go back down. So let's assign these values. So I'm going to say that 1.2 equals cx times square root of 4 minus x squared. And then I'm going to say that 0 equals c times 4 minus 2x squared divided by square root 4 minus x squared. Okay, so we want to know ultimately what c equals. So I am going to first deal with my x value, because as you'll see, we have two unknowns. We don't know what x is and we don't know what c is. But the thing is, because our derivative equals 0, it doesn't really matter what c is, because anything times 0 will just be 0 again. So I'm going to use that to solve for x. So I'm going to say that, and something equals 0 in a fraction when the numerator is 0 and the denominator is not equal to 0. And from looking at what I have in my numerator and what I have in my denominator, what will cause a 0 in the numerator is different from what will cause a 0 in the denominator. So I'm only going to look at my values in the numerator. So therefore, I can say that 4 minus 2x squared will equal 0. Because anything times 0 equals 0, so it doesn't matter what c is. So I can rewrite this as 4 equals 2x squared. Divide by 2 on both sides. I get 2 equals x squared, and x equals the square root of 2. So now I'm going to use this x value, and I'm going to plug it in to this equation here. So I'm left with 1.2 equals c times the square root of 2 times 4 minus root 2 squared. So to clean this up a little bit, I'm left with 1.2 equals c, and then the square root of 2 times 4 minus, well, root 2 squared is just 2, and 4 minus 2 is 2, so 2 times 2. And this is just the square root of 4, which equals 2. So I'll just cross that out and write a 2. So I'm left with 1.2 equals 2c. So now all you have to do is divide both sides by 2, and you're left with c equals 0.6. Now the final part of this problem, part C, the problem says, for another spinning toy, the volume is 2 pi cubic inches. What is the value of c for this spinning toy? So we're also solving for a different c this time. And so we're given that the volume is 2 pi cubic inches, and they told us the volume for this particular shape is generated by revolving it around the x-axis. So I'll write out just the general formula for revolving something around the x-axis, and you get volume equals pi times the integral from a to b of your outer radius squared minus your inner radius squared across whatever variable you're integrating with respect to. So let me rewrite this in terms of what we know. So we know 2 pi is our volume, and this equals pi times the integral. Well, above we calculated that this function will equal 0 at 0 and 2. And then my radius is just the y value that we were given. So this means we have cx times the square root of 4 minus x squared dx. That's my r squared. So now I'm going to rewrite this. I'll cross out the pi's. I'm left with 2 equals the integral from 0 to 2 of c squared times x squared times 4 minus x squared dx. So c is a constant, so I'm going to pull it out in front of my integral, and then I'm going to expand x into these parentheses. So I'm left with 2 equals c squared times the integral from 0 to 2 of 4x squared minus x to the 4th dx. So let's do this integral. So 2 equals c squared times 4/3 x cubed minus 1/5 x to the 5th from 0 to 2. So 2 equals c squared times 4 times 8 divided by 3 minus 1/5 times 2 to the 5th is 32. And then minus 0, because if you plug in 0 to these values, you'll just get 0. So I can say that 2 equals c squared, and then this is 32/3 minus 32/5. So I'm going to multiply by 5 over 5 here, then multiply by 3 over 3 here. So I'm left with this equaling c squared times 160 over 15 minus, not 19, I meant to write 96 over 15, and 160 minus 96 is just 64/15 times c squared, and this equals 2. So now I'm going to do my last step, which is multiply this over, so times 15 over 64 on both sides. I'm left with 30 over 64 equals c squared. I'm going to simplify this by dividing by 2 in the numerator and denominator, so I get 15 and then 32. And then to solve for c, I need to take the square root of this, so I'm left with c equals the square root of 15 over 32. And you might be wondering why I didn't write plus or minus root 15 over 32, but in the question they told us that c is a positive constant, so I'm only going to account for the positive square root. I hope this is helpful, and I hope that you are now a little less worried when you look at this problem. I'll see you in my next video.